Okay, so yeah, today we're going to be talking about TypeScript and like a few advanced steps that you guys might have not known about TypeScript. And yeah, hopefully once this is done, you get something out of it and you get like a new quirky little trick you can put into your TypeScript code. So first we'll start off with why TypeScript, right? So you probably heard of it. It's like this language that checks your code and then compiles it into JavaScript, an easy to read language you would have written anyway. So why may we need it? It sounds like a bit of extra work, like typing everything, and I generally don't like doing more work than I need to. However, there's one key factor we are missing out here. Us humans are generally not that smart, right? So I'm not saying that TypeScript is some omniscient being that we can reduce the time complexity of our code. I mean, if it did, it probably would have our jobs replaced. Instead, it helps us catch errors in our primitive brains might have left in our code, right? So I'm going to show an example here. Okay, so this is a sort function that I took from this guy, and it's basically a merge sort function, right? So it takes an array and just sorts it. And everything looks cool, right? But if we try test it out here, the plugin I'm using here is called Quokka. It's pretty cool. Like as you type, it automatically executes the code. So if we try logging this function, everything seems okay so far, but as you can see, it's a little bit broken, right? So imagine if this function was like 1,000 lines long or even longer, right? It would take forever to try work out like where's the issue and how to fix it, right? And JavaScript in general doesn't have like a very easy way of finding these kind of errors, right? Like unless you like completely like missed a character like this, it doesn't really help you out much, right? So this is where TypeScript might come in. So if we move this function into TypeScript, so you can see that TypeScript is starting to give us some work that it wants us to do, right? So everything in TypeScript is given the any type by default. So, and any type isn't very useful, right? So we want to move everything to a typed kind of version so TypeScript can start checking our code and trying to find errors. So we know we're always going to give numbers in here. So we can do this to say that we only accept numbers into this function. And we can say that we also expect a number out of this function, a number array. And also in this function, we also expect a number array, and we expect another number array, right? And as you can see, it immediately spotted the error here, right? That normally you wouldn't be able to spot too easily. So with just a simple fix like that, and if we try running this function again, yeah, see, it's working correctly now. So we can put like -32, 555, and it sorts it correctly. So yeah, TypeScript is pretty useful to help us find like little mistakes we might make in our code, and it can help us become better developers by just taking all the guesswork and all the like mundane stuff of just helping your code run faster. So it basically brings like the type checking of Java and a lot of other strict languages into JavaScript, which really helps you become a better developer. So yeah, so like I said, it's very similar to languages like Java, C#, and C++, which also have typing. So what makes TypeScript kind of stand out from the rest, right? So there are mostly three ways, and I'll show you them with an example. I just need to. The reason I'm doing this, by the way, is so I have a lot of types here, so this just helps keep the global namespace clean. So pretend that we're making like a graphing application, right? And we might have like a color enum, right? So one thing that TypeScript shares with a lot of other languages is that it supports enums, right? So we can have a color enum with colors like red, green, blue, colors like that, right? And another thing that TypeScript also shares with other languages are like interfaces. So interfaces are kind of like templates for classes. And you can also define a lot of stuff here. So if I had like a shape interface, I can have like a color, a width, and a height. And this question mark means that it's like optional, right? And if I were to make like a class here, I can implement the shape. And what that allows me to do is that it basically already sets these for me, right? So if I were to remove these, TypeScript will complain that I need to add these elements. And it would basically help manage all these type things for me, so I can make like classes that are very similar to other classes. And yeah, so it's complaining here because I haven't defined a default, but once I do, it will go away. So yeah, so it's very similar to like languages like Java. Like, have any of you guys come from Java or JavaScript or anything? Oh, sorry, Java or C++ or anything?
Yeah, I've used Java before.
Oh, okay, yeah. So you'd recognize that all these types are very similar, like enums, interfaces, and all that.
Can you define methods in the interface?
Yeah, you can. So maybe a shape might have like a resize. And so this is all types, right? You can't actually write the function here, kind of like JavaScript. Sorry, kind of like Java. So what you would do is that you can also define function types. So maybe in resize, you might have like a scale value, and that will be a number. And then over here, you would say the type that this is supposed to return. So if it's like a resize function, probably won't return anything. It would just scale the function. It would just probably scale the shape, right? But if we wanted it to like return the shape, we'd probably do something like this, right? So it's kind of like a chaining thing, right? And then once we do that, you can see that the class immediately needs the resize function, and then we can just do something here to scale the width and height, right? So yeah,
cool.
supports functions and all this kind of stuff as well. Yeah, so it looks really similar, but one thing I want to show you is how TypeScript actually compiles. So if I were to, so TypeScript comes with this command tsc, which is what you get if you do like yarn npm install g TypeScript. And if we try compiling this file, and yes, there we go. If we compile it and we look at the code, you can see that it got rid of most of the interfaces and stuff, right? So one really key difference is that these interfaces and all these like types we do, they don't exist, right? Like the IDE also explains it. It doesn't exist at all. It's kind of like, it's only used within TypeScript to help you type. Other than that, it has no purpose, right? So you can see that everything disappears, but you can notice that the enum is still there. So enums are a very special kind of type in TypeScript, is that they actually carry over, they stay with you as you convert your code into JavaScript. So you can actually use them in that regard. So we can see how it looks by logging the color. So this is what TypeScript does when it converts a enum into an object. It actually makes an actual object that you can use, right? And you can see that it is a little reverse mapping. So you can do color 0 to get that color, or you can do color red to get the index, right? But most of the time, you probably don't want to do this because if you pretend you're storing this color inside a database, you probably don't want to store it as an index. So you can also do red equals red and green equals. You can make these whatever you want, but for simplicity's sake, we can just make them the same thing, right? And you can see that it maps it just like that, right? And that becomes really useful. So if you were to serialize an object with this color, then it would just print out this exactly inside the JSON, right? And you can see that these types don't exist because if we try to print them, it says it's not defined because it doesn't exist on runtime, right? So that's a really key difference. Like in Java and stuff, you can still technically play around with interfaces by doing reflection and stuff. But in TypeScript, there's strictly only types, right? So that's like a key difference in how TypeScript works. Okay, let's go back to the presentation. Okay, so now that we looked at like some of the basic stuff of TypeScript, we're going to start going into the advanced stuff. So we've already assigned types to functions, classes, and all this other stuff, and anyone can really do that. But to really harness the power of TypeScript, we have these special operators that let us do pretty special things that are normally not found in other strictly typed languages, such as Java. And all of this is possible because we're still technically writing JS code like you just saw. So I'll show you what I mean. You saw that we can type stuff, right? So we can say let a number is equal to a number, and then we can just do something like that, right? But the thing with TypeScript is that you can actually have union types. So you can say something can be a number or a string, right? And TypeScript will not complain if this was a number or even if it was a string, right? It works for both cases. So yeah, that can be pretty useful in such cases, especially if you make these interfaces. So you can make like special variables that can hold multiple types of objects, right? And you can see that we can go down and we can assign it to like a number, or we could assign it to another string if we wanted to, right? And I'm using this special key combination, which is Control Q on web store, but it also works on, I think in Visual Code, you just hover over it. And yeah, it just allows you to see the type here. And yeah, so let's try looking at some advanced ways we can use all these symbols. So okay, so pretend that we're writing like a special database and we store humans, right? So pretend that we have an interface for humans, right? So a human might have a name, age, and a height, right? And pretend that we also have like a society, which is basically like a way to store these humans, right? So we might have a people, which is an area of humans. And the cool thing is that we can also define it like this, right? They're both the same thing, right? But this format allows you to do a little more stuff, right? Because it has a little like place here for you to just do type stuff, right? I'll show you later what I mean, but they're basically the same thing. And this is a special thing that's happening here. So you can see that it still resolves to a string, right? And putting string here would still give the same result. But what I'm doing here is that I'm referring to the name type of this interface, right? And even though it's still, even though it's basically the same thing, if developers look through this, they can say, okay, so you have this people names array, but I can see that you most of the time just want to put like the human's name inside of this array. I don't just put any string, I want to put the human's name string, right? Like TypeScript doesn't stop you from putting in any string you want, but if a developer sees this, they can say that, okay, I understand that most of the time the name's going to come from here, right? So yeah, so let's move on to, okay, pretend that we suddenly have like aliens or something, right? So let's have a interface of alien. Right, so pretend that aliens suddenly joined us and they want to be part of our society. And let's say that aliens can have like they can have a number of arms, they can have a number of legs, they can have a planet probably, right? And yeah, so this could go for a while. I could have arms, legs, feet, fingers, right? So maybe I can move this out to another type, right? So the type declaration here allows you to basically define any kind of type in TypeScript, right? So we can say limbs, and then we could probably put like arms, legs, and feet as an example, right? And then so pretend that we want to somehow tell TypeScript that I want every single one of these types defined in here, right? And I all want them to be a number, right? So we can try do this, right? So the format for this is we do k string number, right? And you can see that it kind of works here, but if we try put limbs, TypeScript doesn't let us do it because it's saying that it basically doesn't allow unions inside of an interface. And this is because technically we can still take this and make a class implemented. So in order to fix this, we can convert this into a type and change this to in. There we go. So now we can have, so what we're basically saying here is that we want every single one of these inside this type as a number, right? But we can't put anything extra in here, right? We can't put like planet, for example. It doesn't let us. So what we can do is that we can use the intersection type, which is a special type of thing that you can only really use in this kind of context to chain like different types together, right? So we can have an alien is very similar to a human, so we can say that. We can also say that it has a planet, which is probably a string, right? So now we have a type alien that basically combines all these types together. And if we try and make an alien right here, alien and then we implement all members, you can see that it takes everything. So it takes the age from human, arms, feet, legs from this one. And yeah, it allows us to basically combine several interfaces or types and combine them into one. And it's very useful in this kind of context to combine different interfaces and make like super advanced types, right? So we can't use this for like basic variables, like if we wanted to do let num is like string and number, because we can't have like two types at once, right? Maybe if we had like quantum computing in the future, we might be able to have like a variable be two things at once, but for now we can't have an intersection for a variable, right? So yeah, it's mostly reserved for situations like these. And yeah, so let's pretend that we have like an API request coming in that gets like an alien object, right? But with an API, we don't know exactly what it returns, so we can type it as unknown. I'll talk later about how this is exactly used. But in this context, pretend that, yeah, that the alien we get is like unknown. So if we wanted to if we wanted to assign this to like a object like this, it won't let us, right? Because the type here is unknown and it can't be assigned to an alien. But in languages like Java, you can also cast, right? So in Java, you can cast, and in TypeScript, you can also do something very similar, which is casting. So you can cast this to an alien, and then it stops complaining. And there's two ways of doing this. You can do it that way, or you can also do it this way. And they're basically the same thing. So you can just do whichever one you like better. But yeah, that's casting. So it lets you pretty much take types that you otherwise wouldn't know, and it casts them to exactly what you want. You have to be careful about this because remember, this is compile time, so it can't check whether you're casting correctly, but if you know what you're doing, cast can help you get rid of these errors if you know exactly what the type is going to be. So yeah, that's some of the advanced stuff of TypeScript. So the next thing is KEYOF TYPEOF. So you probably already know TYPEOF, it's already in JavaScript, but there's a few extra special things that it can do in TypeScript as well. I have this JavaScript file that I just made up. So it's just like parks generally. And you can see that it just has all these objects and it has these names and all of that, right? So one really cool thing about TypeScript is that it can also automatically generate types for JavaScript, for JSON files, right? So if we try importing this into our file, right, so we can do import parks JSON like that. We can see that TypeScript recognizes that it's a JSON, right? And it's loaded all the types for us. So if we try to get a type out of it, so we can do typeof, and typeof basically gets whatever you give it and it converts it into a type, right? So you can see that it already typed it for us, right? It recognized these names and it automatically typed it for us, right? So yeah, so pretend that we wanted to make like a special like park definition that stores all our parks, right? So you would have like the ID of the park, and this is where KEYOF comes in, right? So we don't want ID to just be any string. We want it to be like a key of this file, right? So we can say KEYOF to basically say, I only want to accept the keys of this file, right? And you can see that it's done exactly that. It's only taken these types. And we can also say size to be small, medium, large, and we can say the location to really be anything, right? And if we try and make a park definition out of this, like that, you can see that this would theoretically kind of make sense, right? Like this file already has everything. The only thing that we added onto was this, right? But it doesn't work because if you read it carefully, you can see the type here. It's take the location as string. The size is string, but here the size is only like a select type of string. So we can improve this by just, so we can make it happy by just taking the size from this one and casting it as small or large. So yeah, it types everything, but it does have its limitations. It's mostly good for getting the keys, right? So KEYOF also works with normal objects, right? So if I have like a object of images, for example, I think I might have to move it into this. Yeah, if I have a object of images, I can also get types out of it, right? So if I have like a type of profile picture data, I can say K in KEYOF type of images. So I'm converting this object that doesn't have any type on it to a type, then I'm getting all the keys of it, dog and cat, right? And I can define a object to, I can define like an object that has keys that are these and extra data like this. So if I were to make a variable out of this, you can see that it exactly has cat and dog. And if I were to edit these, it would not be happy. So yeah, that's basically typeof and KEYOF. You can use typeof to get the type of any variable that you've not already typed, and TypeScript will try its best to try and make a type for it. And KEYOF gets the keys of an object. Basically, it can work with JSON or a JavaScript object. Yeah, so next we're going to look at type generics. So type generics are probably one of the coolest things in TypeScript because they essentially allow you to make really complex functions or classes that may have correct types computed however you want to like make them. So it allows you to basically make types on compile time. Oh, sorry, I skipped one. TypeScript, so type generics are pretty complex. They could probably have a talk of their own because they're just so complex and powerful. Like I even heard in a talk one day that you can make type generics almost like Turing complete. So you could probably make like maybe like a simple calculator even with type generics because they have all the parts of computer. You can do like if statements with them, and you can like compute stuff with them. So they are really powerful. And so I'm not too good with type generics to come up with like really advanced use cases, but I can show you some really neat tricks that let you just make functions, classes, and interfaces that are just a little bit smarter than your average function without these kind of types, right? So we already established that TypeScript already like does most of the typing for you, right? Like if I do this, TypeScript already knows this is always going to be a number and it's not going to likely change anytime soon, right? So, but let's pretend that TypeScript couldn't do that, right? Let's try create a function that does all this typing stuff for us, right? So if we create like a identity function, kind of like this, we can use type generics in order to we can use type generics in order to try and make a function that automatically assigns the type for us, right? So the key thing here is this. So it basically says that we're going to make a type on the fly, and it's going to be, and TypeScript is going to try to predict what it is from using the variables that we've already provided here, right? So if we pass in a val here, it's going to say, okay, this val already exists, so I'm just going to take the type from the val and store it in here, right? And this is really important, right? Because if it didn't exist, TypeScript's going to think that this T is just some really badly named class somewhere, right? So this helps TypeScript understand that this is actually a special kind of type that I'm going to try just make up at runtime, right? So if we have a number here now, we can say identity, then we can put 3 in here, and it basically does the same thing as before. It puts a number, but this is probably the simplest you can go with type generics. It just takes the type here and it basically does what you want. It basically assigns it to the variable. And the cool thing here is that we can actually adjust the type, right? So we already know it's a number, but we can actually put whatever we want in here, right? So now the type here would be 3, 4, and 5. And if you try putting like 6, probably, it would not let you do that. So yeah, these these special type things can actually let you define your own types. And if you don't provide one, it just calculates it for you automatically. Yeah, so let's try and make a special function that adds functionality to our human. So remember we made the human before. Let's try and make a function that kind of like adds the hello ability to it, right? So okay, I already did that there. So let's start from scratch. So we basically want to make a function that kind of like adds a function to that human and allows it to say hello, right? So maybe we can do something simple like this, right? We'll just type things here and we can say the being is key. And we basically want to take the old human and we want to add a new function to it, right? But you can see here that it doesn't let you do that, right? Because this has no like strict thing to say that this being is always going to be a human. There's no way to guarantee that, right? So a way to fix that is to say t extends human. So that's basically saying that I always want to make sure this type is going to be some kind of human type, right? So yeah, that takes it away because now it recognizes everything that's in the human, right? And if we look at this, you can see that it's also using the at symbol here. It's taking the t and it's recognizes that we're adding a function. So it automatically types it as human and a special function, right? And yeah, we can start using this. So we can create like a nice human, which basically takes the this thing we just made, and that's the function to it, right? And we can also do the same thing with an alien, right? So previously, even though it's only saying human, alien extends on human, like I showed you. So it would also accept alien into this function. And we can also be strict about it by saying alien. And if we were to delete any of these fields, it would let us know that we need to add all the fields from alien, right? And yeah, and then if we try use these, we can also have access to this new function that this function has created, right? So it's a pretty cool ability to be able to put type generics. So yeah, so let's try another example where pretend that we had like these colors, right? So we had colors, red, green, blue, and orange, and then we had special colors, which are basically just some the same, some are different, right? This is special, pretend that we wanted to like have like some sort of type that would automatically recognize the types that are present in this one, and it only kept the ones that were present in both, right? So there's a special type that we can try construct here that's called like a filter, right? And you can put multiple types into a type generic, and you can say, okay, if this first type here extends the second type, I want to return it. Otherwise, I would put never. Never basically means that I don't want anything to return here. And if a variable ever ends up with the type never, that means that it will basically just be banned from existing, right? So I'll talk more about it later, but this basically means that it just nullifies the type, right? So let's try making like a special variable that is filtered based on these two, right? So if we look at this type now, you can see that it's taken red and green, which is correct. These types are shared between these two, and it's only kept those, right? And remember, these are all separate types, right? Combined with the union, it's not all one. So what this is actually doing is that it's recursively going through every single one of these types and is comparing recursively with every one of these, right? And it can see that if this type exists in this, then I'm going to return it. Otherwise, I'm just going to not return anything. And Typescript automatically gets the ones that are correct. So this is a conditional statement, which is pretty cool, considering that we can do this inside of just types, right? So I couldn't think of any more examples. So I actually stole this one from the Prism code base. I simplified it a lot to make it a little easier to understand. But yeah, so Prism basically uses layers to try map out. So Prism is basically a map, right? And it basically uses layers to put stuff on top of the map to help you see different types of data, right? And this is directly from the Prism code base. I removed a few stuff to make it simpler, but we would have like the base layer, and it would have interfaces that extend the layer. And yeah, it's pretty cool. And then we have layer types and all that. So this is the part that I was pretty impressed with when I first got into the Prism code base. It basically allows us to, it's basically a really fancy little type that allows us to specifically fetch layer data based on the layer that we want to edit, right? So pretend that I'm like working on the code base and I want to, for example, like fetch the layer data type of boundary layer, right? So just by doing this, and then I pass like boundary layer props, it would automatically get the exact kind of type that, so I just need to set this equal to something. Sure, I'll finish that. Okay, there we go. So if we look at this carefully, we can see that we're taking an L that must be a layer type, and you can see that it only supports these two. So I can't give like a number here, for example, because it's not part of this, right? And all of this is cool, but when it gets down to here, what I'm doing is that I'm getting a key from one of these, and I'm getting the type from this, right? You can see that every single one of these has a type, right? And by doing this, I'm getting the exact type string, and then I'm using that as a key for one of these, right? So I'm basically getting the exact type just by passing in just as simple, just one of these two, and it automatically gets the correct type for me conditionally. So yeah, that's a pretty cool feature that TypeScript has. So we can, yeah, you can see that it forces us to put boundary here, and the data is exactly what boundary data is. It forces us to have a, what's happening here? Yeah, it forces us to have like a number array, right? So that's pretty cool. And if we switch this to WMS, for example, it would tell us to change everything over to the new type. So this would have to be legend. And this type would have to be changed to WMS, right? And this would have to be WMS data. So yeah, that's a pretty cool thing that Prism is able to do with type generics. And we can actually take this a step further by doing a conditional type, kind of like what we did up here. So pretend that we want to add like another type here, like pretend that we wanted to add meta, but we only wanted to add it only if the type was WMS, right? So in order to do this, what we can do is that we can do it add, and here we can say meta string. But what that does is that it also forces the boundary layer to have it as well, right? So we can do a conditional here, right? So we can say if the L type extends WMS, which is basically saying if the type is WMS, we force it to have a meta. Otherwise, it would be just another blank object, right? And now you can see that it's forcing us to add a meta object here, see? But if we switch this over to boundary, and we change these quickly, you can see that it doesn't want the meta anymore, right? So it's very specific. So we can do some pretty cool stuff with conditional typing, right? So yeah, this is a pretty cool use case that is used actually in the Prism database for allowing us to just really easily fetch the correct data type for a specific object. So we wouldn't be crafting these ourselves. There's normally a function to do this for us. But by doing this, we can easily cast stuff to layer data and do a lot of cool stuff with just by calling this one simple thing. So yeah, that's like a quick rundown of type generics. And yeah, okay, so actually there's one more thing I want to talk about from here. So you probably spotted this, right? So it looks a little complicated, but what this basically is that it's part of the TypeScript system, and it allows us to fetch the return type of a function. So you know that date.getTime returns a number. What it's doing here is that we're getting the type of the getTime function, and we're getting the return type of it, right? So it basically allows us to easily convert this into a number. See, number or undefined. So we could have just put that here, but this allows developers to see that, yes, we probably want to set this value to the output of getTime, right? And if we look at these, there's actually quite a few that TypeScript gives, right? So yeah, this is the one that we're using. And it has a few complex, so we're going to look at this one next. But yeah, there's a few, you can try Google some of these, and they all let you like do like a few fancy things with the types you give them. So yeah, let's move on to INFER and IS. So INFER is basically what it says. It just tells TypeScript to make an educated guess on a specific type you give it, right? So this is really useful when you can join it with other types. And yeah, so I'll just show you what it kind of looks like. So pretend that we have like a function to get the temperature outside, right? So this might be kind of like what it might be. So we would just pass like a location, and then it might return a promise with a number. Async functions must always have a promise because they're by design designed to return promises. So they always demand you to have a promise here, right? And you'll probably do some API stuff here, and then you return the temperature, right? So with that information, we might have like an interface that has weather information, right? So we might have wind speed, a planet, temperature, and oh, that shouldn't be there, right? So with the temperature, we want to somehow tell TypeScript that we want the return type of this, right? So if we say like return type, and we use the same thing, so we do type of get temp outside. We have to do type of because this is just a plain function, but type of gets a type of it. If we look at the type here, you can see that it's a promise, right? And if we try construct an object here, it forces us to basically just put a promise, right? And we don't want that. We want to store like the basic value. So what we can do to fix this is we can try and make a type ourselves that kind of extracts the type from this promise, right? TypeScript doesn't come with one, but we can actually make one ourselves. So we can call it just unpromisify. And we know that we're going to get a function type here, and we know it's going to extend a function that just takes any amount of args. We don't really care. And we know it's always going to return a promise, right? It's always going to return some sort of promise, and it doesn't really matter what it holds, right? Now we want some way to extract the type from this promise here. So we can also do another kind of conditional here, right? So we can say if f extends, I think I forgot to put it. I think that's supposed to be equals. Okay. So if f extends, okay, there we go. If f extends, basically the same thing here. But what we can do instead of any is that we can say infer u. So yeah. Okay, yeah, so we can say if f extends this, and we already know that it's the case because we're restricting it here, right? But what infer does is that it basically tells TypeScript to try and guess what the type inside of here is, right? And if this is done correctly, then we'll be able to get the type out of it, and we'll assign it as u, right? So based on that, we can say a conditional. So if you manage to get the type out of it, we want to return that type. Otherwise, we want to return never, which basically will never happen because we forcefully restrict it here. So the main cases I've seen infer be used is only possible in its conditionals. I might be wrong about it, but yeah. So it basically allows us to tell TypeScript to infer and guess what the type is from like another kind of object, right? So from this case, we're doing it from promises. We can also do it with an array or another example. So we're doing the same thing here, and then we can say if a extends array, and then we extract the type that this array is from, right? And then we can return the type of the array, right? The types that the array holds. And yeah, so now if we use this instead of the other one, we can see that it types it correctly now. It asks for a number, right? Yeah, so it does it correctly. If we were to change this into like a string or something, we could return a string. You can see that it also types that correctly. So it carries over just like intended. So yeah, so that's what infer is. It's a little bit complicated, but yeah, it allows you to do some pretty cool things. It's mostly used for cases like these where you want to extract types from something else. But if you have like your own types, like maybe if you have your own promise, if you have your own like interfaces and stuff that take generics, then you can infer types out of it and extract it basically, right? So yeah, and I'll quickly cover is. So pretend that we have like an array of weather infos, right? And we have an API result that is unknown because we just got it from the API. And we want to push this new API result into the array. So it won't let us do that because this unknown is definitely not weather info, right? And we can cast it, but we're not 100% sure if the API result returned a right object, right? This is kind of unsafe, right? So what we can do here is that we can actually make a function to type check this for us, right? So this is a quick example. So we're basically saying that we can check anything, and instead of putting like Boolean or something here, we're putting this in, which is basically saying that we're checking if toCheck is weather info, right? And this automatically processes to a Boolean, but it also has extra information telling TypeScript that if this function passes, that means that toCheck is 100% weather info, right? And you can see that I'm just doing a very simple is null check. So yeah, we can see that planet is the only one that's 100% needed. So if we check that it's not undefined, then we know that it's 100% weather info, right? So now if we use this on the API result, it should let us just push it without any issues. Yeah, see, it doesn't give any errors because TypeScript goes over here and it's like, oh, okay, so you're checking whether it's a weather info, and I can see here that if it passes, then it must be a weather info. So outside, the type of this is unknown, but inside this if statement, TypeScript automatically assigns it to weather info. So yeah, it's pretty useful to, if you're trying to assign if you have like APIs and stuff and you're trying to assign your own type checking, you can use this in order to tell TypeScript that you're doing your own type checking, and it will follow suit. Next one is never versus any versus. So we've already looked at some of these. I sprinkled them a bit here and there, but yeah, they're all pretty special, and they have their own special rules and behavior around them, right? So let's try expose some of those. So any is basically the default type that is assigned to everything, right? So, but we can also tell something to be any, like this, right? And any is basically just really flexible. It just lets you do anything you want. It doesn't really care about what you do, right? It can basically just be anything, like it says. You generally want to avoid this because it basically defeats the point of TypeScript, but it allows you to be a little more flexible with your type checking, right? And there's also unknown, which we also looked at, which basically tells TypeScript that I don't know what this variable is, and I probably need to do some checking on it or casting in order to use it, right? So you normally use this probably for an API request or loading a JSON file, and you're not 100% sure what's inside, right? So unknown is a little more strict. You can still assign it to basically whatever you want. But if we were to, for example, have like, if we were to take our human, for example, you can see that even though this is clearly a number, it just allows us to assign it anyway, because any is basically anything, right? But if we try to put unknown here, TypeScript wouldn't be happy, right? We would have to cast it in order to tell TypeScript that we know what we're doing, right? So now never is very interesting because it just doesn't let you really do anything with it. We can't assign it to anything, and it's basically just sitting there. So it doesn't seem very useful, but we need to remember that TypeScript is pretty clever, right? So we can use that to our advantage. So if we had like a type of animals, for example, and pretend that we wanted to make a switch statement that covered every single one of these animals, right? So you can see that even though I've assigned it to switch the animals, let me just define it in here. Say cat, for example. So it's going to complain here because TypeScript 100% knows that this is a cat. But if we cast it here, then it's going to respect it as any one of these, right? So you can see that I've only implemented these two, but pretend if I add more here, I want to make sure that in the future I remember to update this switch statement, right? So what we can, so TypeScript is clever enough to understand that if cat or mouse are passed in, it would go to a default bracket, right? So we can use this in a sort of way by kind of like making a fake function here. We could probably have like a val that would be never, and then it would return basically nothing, and we would just call this here. So it looks like an empty function, and so it looks like an empty function that does nothing, but realistically, it's actually noticing that we're going from mouse and deer, but we're going all the way down here, and then we're calling this function that has never. So that's illegal in TypeScript, so it complains about it. So that forces us to pretty much make all the other switch cases. And if we do that, it goes away. So TypeScript is really clever. It can work out that there's a default here, and if there's a situation where it can be called, then TypeScript won't allow it, right? So, but if you do something like this, you probably want to comment it. Otherwise, your teammates will probably think you're insane with an empty function. But yeah, so yeah, it's pretty useful. It allows you to basically use the big brain of TypeScript and do a few, just make a complete switch statement. And you can do a lot of clever stuff with it, like with if statements too. You can make an if statement that calls a never function if a certain condition is met. I'm not 100% sure how to use these, but this is probably the most useful case I have for never. And yeah, So let's move on to constructor overloading. So every time I see something that's just remotely similar to the Stack Overflow logo, I must convert it. But yeah, so constructor overloading is basically a way to allow us to add like a bunch of fancy types to our constructors, right? So it allows us to basically make more advanced constructors that can be called with other different rules, right? We can add more rules to a constructor, or we can make it more lenient, right? So I'll show you exactly what I mean. Let's say we have just a class that's just, let's say we just have a class that's overloaded, and we have this num and string. That's, yeah, so, and then to use it, we just say new overloaded, and then we just pass a number in a string, right? Not too hard. But what if we had a use case where we wanted to have a way for us to call this with just an empty one, or we wanted to call it with like either empty or both of them provided at the same time, right? So we can kind of allow this by setting both of these to optional, and this goes away. But if we try to, but we can kind of cheat here, right? By putting just 3, and it still allows it. We strictly want to allow either nothing or 2, right? And we don't want to allow something like this. So to do something advanced like this, we can use constructor overloading, which is basically just stacking different types of constructors in order to provide like different kind of situations where this will be accepted, right? So we can do num. So we'll repeat the same thing here. So this is one constructor that we want to allow, and this is another constructor that we want to allow. Nothing, right? And this is the base one. So the base one always has to be as lenient as possible, right? But the ones that are on top are what are enforced, right? So if we make this strict, then if this one is not going to be possible because this one is strict and this one doesn't have it. So you always want the bottom one to be as lenient as possible. And then as you go up the chain, you make it more and more lenient, right? So you can see here that now we have our desired behavior. We can have 1 or 2, but we can't have midway. So we can't just have number 2 there, right? It's strictly blocked because of stacking. And yeah, that's a pretty cool feature. I think you can do it with functions too. I haven't experimented with it yet, but yeah, like if you just look up function overloading or stuff like that, I'm pretty sure there's a similar syntax for functions too. Yeah, so I think we're almost done now. Okay, the last one is decorators, right? So this is probably the newest and most exciting feature of TypeScript. And Lavish might actually already be a pro here because I'm pretty sure in Angular you have, Angular uses decorators quite a lot. So yeah, so they're basically like little labels that you can put on your code, and based on what they have, based on the code that you give it, you can edit the kind of object and function before it's actually used by JavaScript, which is pretty cool. I'm not 100% sure how to do some advanced stuff with it, but I have one use case that is actually pretty useful, and I can just show how Prism uses it. Prism also has a pretty cool use case for decorators. So okay, there we go. We can use the old one here. Okay. So okay, so pretend that we have like a shop class, right? I'm just going to remove some of these quickly. Right, so pretend that we have a shop, and as part of the shop, we might store stuff like names of the customers. We might store like the shop items, and that would be a string, right? And I'm just assigning defaults here. But yeah, so you might have customer names, shop items, and you might want to type these to something better, but string is just there for example. And say that we also store like the customer card details, right? And that might be like, I mean, you definitely wouldn't want it to be a number, but pretend that all card details are just like one number, right? So yeah, pretend that we're like storing all these details, and then pretend that we want to send this shop object to the user because we want the user to be able to render the shop on their page, right? So what we might do here is that we might log it, right? So we might do JSON.stringify, right? We might send it to the user like that, right? So the customer can see all the shop items, but we definitely don't want them to see the names of other customers or the customer's card details, right? So probably how you would solve this is either like making like an object here yourself and just taking the parts you want, or you could also do something pretty advanced here, which is to JSON, which basically tells, when JSON runs this command, it uses this if it finds it. Otherwise, it just does it itself. But what you could do here is, if we do this, is basically the same thing. But one way you probably would do this is that you would probably have like a return variable that just is a copy of the shop, and then we would return, and then we would probably like remove the ones that we don't want, right? So we would set customer card details to be undefined, right? And then we'd return that. So that does the job, right? But if we were to add more fields here, or if we were to decide, okay, I actually do want to show all my all my customers, other people's customer details, then you would have to remember to update this. And if you rename these, you would have to rename this, and this is just a pain to maintain, right? So we can actually use a special decorator here. So if you've used Java before, you probably recognize that you can probably call like a field private and then transient, which basically means that the field is that Java makes sure that that field doesn't get serialized, right? So by we can use a decorator here instead. So maybe if we have like a special decorator here that says transient, we can tell TypeScript to store this, and then down here we can use that in order to decide what to send to the customer, right? So there are different types of ones you can put. You can put one on a class, you can put one on property names, or you can put one on functions. I'm just going to do the one for property names. So if we wanted to make a transient function, in order to names like this, we would say, we'll just first give it a name. And then we would say the target, which is basically the class itself. So you're given the class. You can also get the property key, which is a string, right? And over here, what we could probably do is that we would want to store the transient keys somewhere. So we could probably store it up here, right? And we'll probably want it to be a string, right? And every time this is called, we would want to add the transient keys. We want to push the property key here, right? And we can just console log this for an example. But if we were to add the transient thing here now, so if we would add transient here, you can see that, just like that, customer names is suddenly available to us down here, right? If we were to add it here, yeah, we can also access customer card details. So even if we rename this, we'll just do whatever, it's always going to update instantly, right? So now this is getting pretty useful. We can, okay, so yeah, we can start using this to serialize our object properly, right? So what we could do, instead of doing this, we can just make a copy of the object, and then we can say transient key store for each. And then for every single key, we just set it to undefined, right? So if we call transient here and it adds to the object, you can see that it automatically removes the things that we just marked transient. And if we remove it, it comes back. Right? So it's a really convenient way to kind of set up this similar type of behavior in JavaScript. Right? So we can make everything transient if we want to, then we send nothing. And we can selectively decide what is transient. And yeah, that's a pretty cool use of decorators. Yeah, they're pretty hard to wrap your head around, especially with classes, but it's probably a really simple use case. And there's a lot of other cool stuff you can do as well with reflection. So I'm storing like just a random array up here, but we could actually do reflection in order to store it inside the variable itself. So I'll jump to Prism's code and show a quick example of where they do it over here. So they actually have their own decorator. And they use this thing called reflect that basically allows you to attach data onto a class, right? So they're taking the class and they're attaching data to it. And this optional thing is just a symbol. It's just like it's constant, right? And yeah, they're basically attaching string data to it, right? And if we see where this is used, these are the layers I talked about earlier. They're assigning certain fields to be optional, right? And they can actually use this. So if we find where this is used, okay, that's not it. Check. Yeah, this one. They're actually using it to, they're using the decorators which are done in compile time in order to check in runtime whether the key is existent or not, right? And you can see that they're getting the required keys using that same key, the reflect thing. This was populated before using the decorator, and just like that, they can access all the optional keys, and then they can run type checking. Yeah, so they're calling this function for every single type, right, from JSON, and just by using that simple decorator, they can very easily mark fields as optional or mark fields as required, and yeah, they can do some pretty cool type checking here. So yeah, that's a really cool example of how decorators are being used to just make your life easier, right? So yeah, I think that finishes most of the advanced stuff. So yeah, now we're just going to look at some quick examples, right? So we're going to try to create these three things, these four things, and we're just going to try and look at how, if we were developing these functions, how we would type it.
Yeah, we are over an hour now. Try to wind up within another 8 to 10 minutes.
Okay, sorry, realized it took so long. Okay, we'll just quickly go through this. So pretend that we're going to make React state. I already have it written up here. Okay, so yeah, so if we were making useState, right? If we look at how it's used in Prism frontend. Okay, let's just ignore that. Okay, so if you've used useState before, you know that if you've done it with TypeScript, you know that it automatically decides what the type of your object is based on what you put in, right? So if I put F in, it automatically decides that it's a string, right? And we can use the stuff we just learned to try and understand how the React devs might have made this function, right? So they use type generics like we learned before, and they have a tuple here, right? So they have a array, and they know the first element is always going to be the state, and the next one is either going to be a function that edits the state, or it's going to be a function that returns a previous state, right? So if we use set state, we can either put like a new state, or we can say previous state, and then we return a new field. So yeah, that's a quick example of how the React devs might have typed the useState function, right? And yeah, just because of that, we're able to get like really nice type inference. And if we want, we can also give our own type, right? So we can say FOG, right? And then this is also applied to the same system. So if we try put 5 here, it won't let us, right? So yeah, that's one cool example of how they might have implemented set states. And we'll also look quickly at object keys. So yeah, so if you've used object keys before, you recognize that it doesn't really have a lot of good typing. It just returns string, right? But from what we just learned, we could probably make it a little bit better, right? They probably have a genuine reason of doing this, but just for fun, we can try and make a function that types the object.keys method better, right? So we can say that T always extends an object, and we can use the same function, but we can also say that what we return is always going to be an array key of T, right? And if we do this here, you can see that the keys up here match these, right? And if we were to do it just here, it's not able to do any of that. So yeah, that's like a cool example of how we might use like the type generics as well in order to make like the object.keys method a little bit better, right? If we were to update this, these would update too, right? So yeah, and this is a little bit big. We could skip that if we want. Okay, we'll just look at typing in React. So now that we've seen all this type stuff, we can quickly see how we might use it in a React application, right? So I have it set up here. So TypeScript basically acts the same as how I just showed you, but there's like a few extra stuff, very, very, very simple stuff that's just added on top of it that helps make all the typing better, right? So when you have props up here, whenever you give a type here, React automatically forces it as a real thing, right? It forces the type onto the component. So you can use it as a simple way of defining prop types if you use prop types before, right? So this is complaining because it could probably be, oh, it's because I got rid of it. Yeah, so you can see that if I update the types here, React automatically allows us to mess with the types and easily catch errors that we might have been making when we're passing down props to our components, right? And we can make these optional and do all of that, and React automatically decides exactly what's happening, right? It helps you catch errors when you're passing down props. And you can see we can pass numbers, but not strings. So this was previously achievable with like, prop types, which I use somewhere here, I think. Yeah, it's previously achievable with stuff like prop types, but with TypeScript, we can actually enforce it strictly within the language. So yeah, that's how you would use types within React. And yeah, we'll just finish it there. Yeah, okay. Do you guys have any questions?